Okay, today we're going over the HiSet free practice math test, FPT-6A, and we're almost finished. We're on problem number 17. This is a question about the perimeter of a triangle, but honestly, you don't really have to know a lot about the perimeter of a triangle to figure this out, because what they're wanting you to do is they're wanting you to solve for n, and they give you the formula right here. So they're giving us this formula, P equals 2n plus b, and it says which formula is equivalent to the perimeter formula but is solved for n. So when you're solving something for n or for any letter, doesn't really matter what the letter is, you're going to be moving things around. Okay, so keep that in mind, that that's how this is all going to work, is they're going to want us to move these different things around. So our original formula is P equals 2n plus b. I'm going to go into my program here. P equals 2n plus b. And what they're wanting us to do is solve it for n. So what we're going to do is the same thing we would do any other time we're solving for n. We've got the n on the right hand side of the equal sign, and the p is on the left hand side of the equal sign. So I want to try to keep things as easy as possible without dealing with a lot of negative numbers, because I don't like negative numbers. So what I'm going to do first is I'm going to take this b and I'm going to move it over. And to move it over, I'm going to subtract it from both sides. Okay, so now my new formula will be P minus B equals 2n. All right, so far we haven't done anything drastic. All we did was, since we were adding the b here, we're going to subtract it from both sides. Same way you do with algebra all the time. Now we have P minus B equals 2n. We have to do something with the 2. So if we're multiplying something by a 2, the way we're going to get rid of it is we are going to divide. These two numbers will divide out and leave an n by itself on this side. So the n is by itself. And at this point it doesn't matter which way you write this. You can write it n equals, or you can write equals n, whichever one you're more comfortable with. Same thing either way. P minus b over 2. Or you could write it like this. They both mean the exact same thing. They're both telling us what n is equal to. So we're going to go back over here, and what we're wanting is n equals p minus b divided by 2. So 6 is going to be your answer. We were able to do that without having to really do anything with the perimeter formula other than solve for n, which is what they wanted us to do. Okay, this next one is very, very confusing. And I'm going to tell you that the way I worked this problem out was I didn't know how to do it. I wasn't really sure which approach to take for it to start with. So I went through and looked at everything that the question had for us, trying to figure out what it was that they wanted me to do with it. So let me move this over, and I'm going to show you how I ended up working this problem. And you know, sometimes process of elimination, unfortunately with math, sometimes that's the way it's got to be. Okay, so I want to figure out what I do know. And something that I know is that usually whenever you see expressions that look like this, you're usually able to break it down using the double parentheses, right? And when we do that, we take our first term and we put it here. We take our second term and we figure out what we'll multiply to give us that term. Then our third term should be adding these two out using the FOIL method. The problem is it doesn't work that way. This particular problem is not going to work using this method. So that tells me that I'm going to have to be kind of creative with this. What they're looking for is an expression that is equivalent to this. So because I'm not able to do something like this, I'm not able to eliminate what's on the bottom. I'm going to have to look at this a bit differently. Because of that, A and B are not going to be possible answers. Now what I'm looking at is my other answers that I have here, and I'm going to have to work from the answer to the solution to try to figure things out, okay? So what I'm looking at with each one of these possible answers, each one of them is set up so that we have what's considered a whole number. See, they all have a whole number right there, even though we don't really know what that number is. And they all have a fraction, right? These are fractions. And then in the middle, they all have an addition or subtraction function, okay? So I'm going to have to work from the answers to figure this out. Now here's the deal with this, okay? Whenever you're adding or you're subtracting fractions, there are certain rules, right? Fractions, the main rule is this wonderful thing called the least common denominator, okay? To be able to add two fractions, you have to find the least common denominator. That is the smallest number that both of these numbers will go into equally, all right? We're lucky in this. If you'll look at the bottom expression, let me find a different color here. If you look at the bottom expression of all of these, x plus 1 is the bottom expression. And what we're essentially doing here then, let me go up to this, x plus 1 is our bottom expression here too. Okay, sorry about the background noise. I paused for a minute and now I'm going back in. Okay, so for our denominator, for both the original problem and for the solutions, we have x plus 1. All of this is coming together to tell me that what's actually happening here is that we are adding fractions, all right? Now, I want you to look at these first terms here, here, and here. We're going to have to put those terms over a 1, and now we have full fractions, okay? But to be able to subtract or add fractions, we have to use the least common denominator. So what we're going to have to do then is we're going to have to work through each one of these three as quickly as possible using least common denominator. So I'm going to take the first one, x plus 2, and I'm going to put it over 1. And I want it to give me something that's going to be equal to x plus 1 with something over the top of it. Okay, I don't know what it's going to be yet, but we're going to figure it out. So the way you use least common denominator is you take this denominator and you divide it into this one, and then you take whatever that answer is and you multiply it by this to get this answer. Okay, so 1 will go into x plus 1. Guess how many times? X plus 1 times. If we take that x plus 1 and multiply it by x plus 2, then we get x plus 2. Okay, so that's what we're looking at right now, is we have x plus 1 times x plus 2 over x plus 1. Now I'm going to write this a little bit differently so that you can see it a little more clearly. X plus 1, x plus 2, and that's all going to be over, it's all going to be over x plus 1. Okay, so this should not have an underline on it, so just kind of ignore the fact that I underlined that part. Okay, so x plus 1 multiplied by x plus 2 over the x plus 1. What we're going to end up having to do now is use the FOIL method. So with the FOIL method, x times x gives us x squared, okay? 1 times x gives us x, different color. X times 2 gives us 2x, and then different color. 1 times 2 gives us 2, okay? And all of this is over x plus 1. All right, so now we're going to add and subtract these out, and we get x squared plus 3x plus 2 is going to be our numerator, and x plus 1 is our denominator. Now I'm going to go back up to my original answer right here, and I just want to look at it for a minute, okay, to kind of see what's going on and to kind of see, you know, where everything stands. So this right here has become our new first term, all right? So this is the new first term over x plus 1, all right? Now let me change the view just a little bit on this and make this a bigger piece of paper so we can see exactly what we're doing. Okay, so I cleaned this up a little bit and typed it right here, but essentially what I did is I took this expression, which took the place of this x plus 2 over 1. These guys mean the exact same thing, okay? So now I took that expression and it's right here. I went back to my original problem and put the next part of the expression, which is right here. And this is, I'm subtracting the two of them from each other, so that's why I put this little minus sign down here to let me know what I was doing, okay? Now I want to take this and make it bigger so you can see what is happening. So what is actually happening here is I have now a least common denominator, and that least common denominator is the x plus 1. So now I can take these terms that are on the top and I can do the addition, subtraction with them, all right? When I do that, oh, this is supposed to be an x squared. Sorry, I forgot to write my 2 in after I typed, okay? So when I do this, I'm going to end up with x squared plus 3x plus 2 minus 1 gives me a plus 1, and all of this is over x plus 1. This was the original problem that I was given right here, okay? So once we get C worked out, we don't have to work out any of the others. If we were to work out the others, all we would be doing is we would be taking the x plus 3 and multiplying it by x plus 1, and then using that, multiplying and adding it out, then adding 1 to it, and finding that answer to try to figure out which one of these will go back to equal this, okay? And that's the only way I could figure out how to do this problem, is treat these as fractions, which they are, treat this as your first expression, set it up with least common denominator, which is this right here, and then use all the rules that you know for finding least common denominator and how to change a number from being over a particular denominator to being over another denominator. And that's all you're doing with this particular problem. Even though it looks really complicated, it's simply adding and subtracting expressions that have a least common denominator.